Section 1.5 is about problem-solving strategies and models. The examples they give you are relatively straightforward, so I would suggest that you focus on good problem-solving procedures. So for example, in number 2, they're asking you to use the formula distance equals rate times time, and they tell you D equals 120 miles, R equals 60 miles per hour. And I always write rates or fractions with a numerator and a denominator. The slash is not helpful, and the question is T. So if I replace 120 miles equals 60 miles per hour times T, I would divide by 60 miles per hour. So I have 120 miles, which means I have 1 hour over 60 miles. Dividing by a fraction is like multiplying by the reciprocal. And then my miles cancel, and the zeros cancel, or divide or reduce. And 12 over 6 is 2 over 1, so 2 hours. T equals 2 hours. I'll go back. So what did I do here? Dividing by a fraction is like multiplying by the reciprocal. That's what I did here. 1 hour over 60 miles. I'm left with T on this side, and change everything to a fraction. And again, you might say, well, I can do that in my head. Sure, you could. But practice good problem-solving strategies, and unit analysis in particular will help you in other disciplines. Numbers 5 through 8 are rather similar. In number 6, in this case, they're asking you to use the formula area equals base times height, and they tell you A equals 8 feet squared, 8 square feet. They want to know what B equals, and they tell you H equals 2 feet. So in the last problem, I would have rearranged the equation for base, divide both sides by H. So base equals area divided by height. So base equals 8. Feet squared is feet times feet. That's how we get area, length times width, dimension times dimension. I'm going to divide by 2 feet. One set of feet cancels, and 8 divided by 2 is 4, and sure enough, my answers are in feet. Look for a pattern in the table. Number 10, I have an X and a Y. We don't normally express tables horizontally, but I believe textbooks do that because it's easier in terms of font and that business. Now, you could just start floundering with this. So let's see. 0 plus 6 is 6, but 1 plus 6 is not 10. Well, maybe it's like times 3 plus 2. Well, first of all, if I have 0 here, I know 6 has to be where I started. So if you think about this as a linear function, this point is 0, 6, so my vertical intercept is 6. So I must add 6, because if you multiply anything by 0, you're going to get 0. So in the end, you must add 6. So if I'm going to add 6 to get 10, I must have had 4 to start with. So 1 times 4 is 4, plus 6 is 10. 2 times 4 is 8, plus 6 is 14. That checks. So y is equal to, I started with 6, and then I had to do 4 times whatever x was. And then likewise in number 12, I have 0, 150, 1, 125, 2, 100, and 3, 75. So again, I must have started with 150. So if you want to think about that, you say, well, something has to go here, x, and then I'm going to add 150. Well, what happened here was I actually need to go down by 25. And then let's see if that works here. 2 times negative 25 is negative 50, plus 150 would be 100. So that works. Again, that takes some practice and whatnot. I'm looking at the last 3 word problems, and they look relatively straightforward. I would just encourage you to use units and the like. In number 14, they want to know what must your average speed be? And we're fairly familiar with speed being expressed in miles per hour. And so speed is distance over time, or your rate. And in this case, it's 260 miles over 4 hours. 4 goes into 21.5 times, and 16, so it must be 54 miles per hour. You could say mph, you could express it like that, miles per hour. But again, anytime you're going to, oops, here I go again. Anytime speed is distance over time, 216 miles over 4 hours. 4 goes into 21.5 times with 16 left over. 4 times 4 is 16 miles per hour. Here's other ways to express those units. If you're going to be carrying this through in another problem, numerators and denominators. Working with fractions, make it a fraction. These don't help us. I have confidence you can do those.